Video is to share with you metacognitive learning strategies that I'm sure will help you maximize your learning. We have an exam coming up. It's going to cover the first 3 chapters of the textbook. So it's really important now to make sure that we're using the very best strategies that will lead to your success. I've taught this course many times, and here's the very typical distribution of results for the first midterm exam. Now, whatever bin you would score in, I'm really confident that by using evidence-based learning strategies, you can move up. You can move up 1 bin, even more than that. So let me share with you in this video various evidence-based learning strategies. I know these work because I've collected data. Within this slide on the bottom, I show data that I used with a pre-class assessment. This was right at the start of the semester and was a gauge of the students' prior understanding. Above that is how those same students went on to score on the first midterm exam. Now, one thing you'll notice is students that had larger prior knowledge when they entered the course, they were more likely to do well on the test. But if you look more closely, look at this very wide distribution. For the same amount of prior knowledge, some students might score in the 30s and others up near 90. Same thing with this column, even more dramatic. Even if you look at the students that entered the class with a great deal of prior knowledge, there was a wide spread. They might score close to 70 or close to 100. So analyze that data for me. How would you interpret this? If students enter with the same amount of prior knowledge, but there's a wide variation in their performance on the test, how do you explain that? My explanation was that the students had different learning practices that they employed once they were in the class. Some students were employing learning strategies that were very successful, and others were employing ones that were not. So I went on to study this. Here I show some data for 2 different classes that I had, in the evening and in the afternoon. These were my typical students. Typical meaning I did not share with them any metacognitive learning strategies. And this is how they scored on the pre-assessment and then in the class, on the first midterm. For another group, I shared with them metacognitive learning strategies. The dark lines are taking the same fit and just bringing it over. What I found was that the students that received the metacognitive learning strategies were 3 times as likely to outperform their expectation. They were 3 times as likely to do better than I would have predicted. So since then, I've really prioritized we need to all learn these best metacognitive learning strategies. Now, I've used the word metacognitive several times. What is metacognition? Is that something you've heard before? What does it mean? Most broadly, we could think of metacognition as thinking about our own thinking. Crucially, it's going to be a way in which we monitor and control our learning and assess our understanding as we move through the course. Here I show Bloom's taxonomy. This is something you may have heard of before. This is set up to show how we can construct different ways of learning. At the bottom, we find something involving knowledge. That rises to comprehension, application, analysis. Look at the pyramid as it goes up. The kinds of skills involving knowledge would be information that one memorizes but does not really understand. Comprehension is more advanced. It's taking ideas and being able to summarize it or translate it to a new environment. Even more advanced than that would be applications. When I look at these different categories and I see our exams, about 20% of a midterm exam involves recalling knowledge. And students do a great job on that. Scores are about 95%. Comprehending, that's about half the test. Those are more difficult. Scores would be about 50 to 75%. And about 30% of a midterm exam involves applications. And those are the lowest scoring within the group. So how do I interpret this? I think you have outstanding skills for knowledge. You have outstanding skills to memorize and recall information, but we're not going to ask that. That'll be part of the test, but most of it are application and comprehension questions. So I view our goal as moving you higher on Bloom's taxonomy. You need to have the best skills in order to do the more higher end tasks. So let me share with you effective metacognitive learning strategies. These are not things that I've made up. This is what cognitive scientists tells us. So I have a host of different things that you can be doing, and I break them down by what you could do before class, in class, after class, and when you prepare for a test. Let me step through some ideas here. So first of all, you notice using perusal is a pre-class assignment. I show here the distributions of scores that I've seen for the first 4 different videos. If you recall within here, perusal scores a given annotation on a score of 0, 1, or 2, and then it uses the 4 highest scores when it compiles the overall score for an assignment. And that I consider scores of 2 or 3 to be full credit for an assignment. What I see here is the students in the class, you all are doing a great job of using perusal. One suggestion, answering a classmate's question is a really powerful way to improve your own understanding. So that's something that you might want to try. How about using the textbook? Are you someone who highlights a textbook? Is that a strategy that you use? Share with me your own insights. What the data shows that when it comes to highlighting a textbook is close to useless. Highlighting a textbook does not require any mental input. Taking notes, that's a much higher level skill. It's more beneficial. Now, if you return to a highlighted text, it doesn't provide any useful output. Your notes are useful to return to. A highlighted text is not. That's what the data shows us. So let me highlight that. Highlighting is going to take up time and it does not increase your retention. So we need to do better. What would be better? Previewing the chapter and making a map. This is a really effective tool. The textbook is already set up in a series of different headings, subheadings. It's really difficult in our lecture to hear information, process it, and connect it to other information. You can get a head start of that by simply previewing and giving yourself an outline for how the ideas are going to fit together. Active reading is even better. Active reading involves reading a passage, stopping, thinking about it, putting it in your own words. Doing that in stages and connecting one set of ideas to another. I had a student that told me, this is the first time a science textbook has ever been helpful. I used to read it, but now by using active reading, I actually find information I can use. And I said, well, you got to show me what you're doing. He pulled out his piece of paper, and this is how he was stepping through the textbook. I should add, this was a senior at OSU. He had gone his entire undergraduate career, and he never knew how to extract information from a science textbook. If I were connecting this to perusal, I would use the textbook after working on the pre-class perusal video. And I would direct my attention to the objectives and things that I did not understand that were present in the video. I wouldn't necessarily be reading the entire chapter that way. I'd use it as a targeted tool for the areas that I needed to work on. What about when you're in class? Strategies for in class where you have to go to class, participate, and then review, and then also taking notes by hand. Now you might find that our lecture moves too fast. Ask yourself, are you able to answer the questions along the way? Are you able to pick out the learning objectives and typical exam questions? Do you remember what we learned? I view our class as sort of a progression up a series of steps with the ideas becoming more complex. And sometimes those steps can just be too steep for you. How do you make the steps more manageable? Preparing ahead of time is a great thing to do. But preparing ahead of time and being in class isn't helpful if you don't remember what we talked about. Here's a model for what it means to make memories. We get a lot of data that is in our sensory input in the world around us, the things that we see, smell, hear all the time. Most of that is lost. A very small amount of it enters into our short-term memory. We want to be able to take it from our short-term memory, though, and put it into our long-term memory so that we can keep it. There's different ways you can do this. One way that you can do it is what's called rehearsal. This means saying the information again and again and again. I've never run the class like that. Instead, what I've tried to do is another strategy to take it from the short term to the long term, and that's trying to think about the meaning of it and make connections to information that we already have. That's what it means to be able to have an approach that's going to store information in our long-term memory. Now, another thing to point out, notice this arrow goes back and forth between the short term and the long term. When you recall information from your long-term memory and bring it back to your short term, that strengthens your neural network there. It strengthens your ability to have that memory. So here's a great strategy for you. This one works really well. One strategy that you can do is to mentally review and recall class information without looking at the notes later in the day. An hour later, 2 hours later, just ask yourself, okay, what were the 5 or 6 main ideas that we covered in class? Try to recall the information. That will strengthen your memory and the connection between your long term and your short term. Do that later in the evening, do it the next day. This is a really great way to help recall and memorize information. Taking notes by hand, that's another strategy that helps one sort of code and record the information. How about after class? A couple things for doing after class. First of all, much of our course, just like you might encounter in math or physics, you see a lot of worked examples. Worked examples sometimes I might include in my lecture, or they might be within the textbook. Do you know how to learn from a worked example? What do you do? Share your insights. Research has shown that the best way to learn from a worked example is you really need to engage with it. You can't just read it, nod your head, and say, yeah, that looks right. So a couple things you can do. Look at the worked example and ask yourself, what information is in the worked example but was not in the question itself? What did the problem solver have to bring to the question? How was the question asked? Would you be able to identify similar problems? You must elaborate on the worked example. Explain it in your own words. See if you can modify the question. Can you identify the main error that someone might make? What error would you have made? This idea of pairing a worked example with your own self-explanation, that's one of the most powerful learning strategies you can possibly do. You can't be passive with a worked example, but if you are actively engaged with it, it really helps. Now, when it comes to doing homework, most students do homework this way. They looked at an example problem in the textbook or in their notes. They try to copy those same steps or look for a pattern to get the correct answer for a different question. That's what I would do all the time in a calculus class. Oh, this is solving for x. Let me look back to a worked example. Okay, now I can see what it would mean for x squared. Turns out that's exactly the wrong way to do homework problems. Anytime you have a homework problem or an example problem you find in the textbook, use that as an opportunity to test yourself. Before looking at the homework, try to actively study the material. And then when you do the homework, try to see if you can authentically answer the questions. You are never going to have notes or additional resources that you can quickly return to on an exam. I have so many students that will say, oh yeah, it's easy when I see the worked example. It's easy when I see you discuss it in class. But then I miss it on the test. It's because you've never authentically tested yourself. So many students, when I say most insidious of all, we tell ourselves, oh yeah, I know how to do that because I saw someone else do it. We need to authentically test ourselves. So here's a plan for learning. When you have the worked example, first review the material, then try to answer the question and give yourself an honest evaluation. Would you say the topic's easy? If it is, you can move on. But if it's not, try to learn more. Simply answering a question does not mean understanding it. Where might you learn more? Maybe it's the class notes, textbook, TA, come to office hours, in recitation, and then try to retest yourself. We have many questions that are end of chapter questions or in the online homework. This idea of making mistakes along this process, excellent. If you make mistakes there, make a note of it. You want to be making mistakes when you practice and not on the actual test. This idea of can you teach it? This is a really powerful learning strategy because you are offering an explanation. Here's a cognitive study that really blows me away. Within this one, what they did is they had students answer questions. In some cases, they just answered the question and they did not offer an explanation. In other ones, after they were done answering the question, they explained what they did. Concurrent self-explanation is as they were working, they were sharing their insights. Notice for problems that were called concrete, where there was a simple plan, it was better to have concurrent self-explanation. But when it was a more abstract problem, look at this huge difference. This just blows me away. Look how so much better if you are explaining it along the way versus just trying to solve it and not offering that explanation. Why do you think this is? Why do you think concurrent self-explanation is so powerful? One reason that occurs to me is that when it comes to concurrent self-explanation, it provides great metacognition. You can tell if you're bullshitting yourself. If you say, well, I get to the end and then I hope to find the answer, that is not a good strategy. If you can't explain your process as you go along, you probably don't have a good process. Now, the strategy of learning from homework, when I look at course data, if we have a deadline for homework at midnight, the exam, the completion start to roll in, and then it really spikes up close to the deadline. This is difficult to learn from because you're trying to just finish it. You're not trying to process the information. I look at it this way. Let's say you're having a skateboarding class. You have a schedule where the first day you learn about the equipment, and then you move on to starting and stopping, and then you start turning. I think it's really important to schedule your learning. You have to learn the first step before you can move on to the second step. So don't wait on the first step, because you know it's going to get really complex with a lot of other things that you're going to have to do. Do I know what these other skateboarding moves are? I don't, but they sound difficult. They sound difficult, so I know you've got to get the basics down first. Now, when I think about chemistry and skateboarding, and I think about metacognition, I think I understand why skateboarders are good learners. When it comes to skateboarding, it provides excellent metacognition. They're testing themselves all of the time. And it tells you right away, they're just not watching someone else. They're trying it. And they learn right away whether they can do something or not, and then they can improve on it. I also find skateboarding very high on Bloom's taxonomy. They're not just on this flat surface going left and right, left and right. No, they're doing all kinds of things. They're very high in terms of application and pushing themselves. Same thing applies if you're trying to learn chemistry. To finish up here, when it comes to preparing for tests, this idea of aiming for 100% mastery, not 90%, you know how it goes on a test. If you know how to answer something 3 out of 4 times, but you have one weakness, that weakness always shows up on the test. If you're identifying a gap in your understanding, if you're not at 100% mastery, try to fill that gap. Another is to consolidate your study material. We have a lot of different sources of information. It might be in perusal, it might be end of chapter problems, it might be the notes that you're taking. Consolidate that information. Bring it together in a way that is meaningful for you. This is called transforming instructional materials. When I've studied this, this is a huge thing to do. You don't want to just passively go back and say, oh yeah, we had notes on this. You want to take that and make it your own. This is one strategy that I used as an undergraduate, about the only one in this whole presentation that I was aware of, and it really worked well for me. I think you can consolidate the information now in chapters 1 and 2. In each of those chapters, try to bring those together, those ideas, summarize them, about 1 page for chapter 1, about 1 page or chapter 2. See if you can do that. So we have strategies we can do before, during, after class, and then preparing for exams. They go from passive strategies to the most active. I really encourage you to begin using active strategies soon. If you don't begin to adopt them now, I don't think you will later on. This whole middle group of strategies, these work and take very little time. Outlining and previewing the chapter, being able to treat the class as a self-test, this idea of reviewing before you do homework, learning from worked examples, consolidating your notes, all of these are going to be very effective. The most effective ones, they all reinforce each other. If you are doing the best approaches before class, it helps you in class, helps you after class, and then for exams. And I'm trying to set up the course that will encourage you to use the very best practices. One thing that we still have coming up as far as preparing for exams, I'm going to be sharing practice exams with you that will be paired with feedback. Do your best now to be learning the ideas in chapters 1, 2, and 3 so you can use those exams authentically. I view us as being in this together. Okay, I like this picture because it looks like they're wearing their own little lab coats there. I'm really confident that by working together, we can achieve uncommon results. I think everyone can do outstanding in this class. Now, help me out real quick. This presentation, what has it done for your confidence in this class? And tell me why. Are you much less confident? All the way to you're much more confident you can succeed. You can give me a number, but also explain why. I'm really interested. And last question for you. How would you respond to this? To succeed in this class, I need to use different strategies than what I used in high school. Where are you? 1, 2, 3, 4, or 5, and explain why. Tell me your reasoning. I really want to build on your response and lead us to do an uncommon thing, which is to have everyone in this class just do outstanding on the first exam, second exam, third, and the final. And I think we can do it. I think we're in this together, and that by working together, we can achieve uncommon results. Let's make that happen.